Thanks for joining us today on the last webinar of ReliaSol's this year. This is a very special meeting for us, not only because it's the last one in 2021, but also because this will be a premiere of our brand new approach to PdM solutions that we packed up in RSIMS Apps that we will talk more about in just a few moments. Please let me know that you can hear us and then you can see the three of us well. You can write us on the chat. Oh, okay, great, thank you. Okay, so let's meet our presenters. Today's presenters is Piotr Lipnicki, CEO of ReliaSol, and he's also responsible for the strategy and technology in the company. He's well known as educator in PdM and AI topics. So welcome, Piotr. And today also is with us Grzegorz Mika, data scientist at ReliaSol. He's responsible for data analysis and building anomaly, PdM, and prescriptions models. So welcome, both of you. And just the technical stuff. Today's meeting will last about 30 minutes. And as it is a premiere of RSIMS Apps, you'll probably have some questions to us. So feel very welcome to ask your questions on the chat. We'll try to answer them during the meeting. And well, yes, without any more ado, I'll leave you in good hands. Piotr, the floor is yours.
Okay, thank you, Kasia. Welcome, ladies and gentlemen. I would like to briefly tell you what's the agenda for today's presentation. We will start with reminding who we are, what we do, and also what is our approach to predictive maintenance. And then we'll try to answer two questions: why we created the applications, the RSIMS apps, and what makes them different with our traditional approach. And then we will introduce 4 different kinds of applications and functionalities which they can deliver. And after all, we will try to summarize the whole presentation and applications as we speak. So, making the introduction short, we are a company which delivers AI-based predictive and prescriptive solutions, which can help you to monitor the health score of the dashboards of the failures of the predictions of your machines. And we can also diagnose and help you to pinpoint different kind of problems and challenges that you are having. And as I said at the beginning, traditionally we were working with the RSIMS platform, which is delivering this whole tool chain and value chain connected with digesting big amounts of data, building models, and getting into the prediction on a higher level, integrating with DCS or SCADA. The applications, those are the ideas actually which came up during a couple of projects with customers, standalone software packages that their aim is to be fast and efficient in terms of PdM implementation at lowest possible cost. So we try to cover the most critical PdM functionalities and features there. So this is something that we want to talk about today and to deliver this to you. What are the challenges and the opportunities that we are actually facing today? I'm pretty sure that all of you see that we have to stay competitive and we want to have our production rolling without any disturbances that are not planned. Of course, increasing maintenance costs, safety risk, and rise of the downtimes can bring a lot of headache to operational people. But also more and more we are trying to put insight on reducing the carbon footprint. So this is something that every production site has to cope with, and delivering predictive maintenance solutions can help you to achieve those goals. And if you think about the RSIMS platform and RSIMS predictive maintenance apps, it really depends on the level of the solution that you want to deliver. So as I said before, RSIMS provides the highest level of accuracy that is seen for the solutions developed in your factory's plants. But RSIMS apps are enabling fast and efficient PdM implementation. So we are focusing and pinpointing the, let's say, solutions that are allowing you to decrease the level of getting into the PdM deployment. What is it all about? It's just we provide those standalone packages that are focusing on a couple of features. One is connected with anomaly detection. The second one is the correlation monitoring, trend monitoring, and change point detection. So in principle, we want to deliver fast solutions which are allowing you to deploy the insights to the needs on a let's say lower level in terms of machinery signals, but also single production lines. The goal is to be able to pinpoint anomalies and detect those changes in the process or in the behavior of the machinery in a way that it helps to govern your solutions of maintenance in a robust and scalable manner. So that's long story short. What is the reason behind getting those applications? As we are quite experienced in delivering the predictive maintenance solutions, we often observe a couple of things. Usually when we talk to the customer, we start with describing the challenge together or the problem. Then we are verifying what's the data availability and quality. And in the end, we are going to the business value assessment. And depending on the case, sometimes using AI and machine learning solutions on a high level, integrating a platform, etc., is like shooting from a cannon to a fly. And maybe it's better to go for some lighter solution, which will deliver you the value almost immediately without requirements having in terms of historical data. And what are the situations that we are actually recommending replacing this comprehensive and large-scale implementations? First one, if you want to test the PdM, if you want to just check what you can do and verify, for example, anomaly detection and prediction on your machinery in real conditions, starting really fast. And you also usually want to start somewhere, but you are not really sure how this works, what are the needs and what are the requirements. So just starting with one small application will give you, let's say, overview of the possibilities that you can have and implement. And second one is you have different resources available in terms of people availability, system, etc. So in short, your needs need to be addressed properly. And in which industries this really makes sense to start with the applications? In practice, in all possible segments in industries, but those applications are also really good for the industries where you have a lot of islands of automations or the data is not concentrated in Historian, DCS, or SCADA. Although they work also quite well in those conditions. But if you have some smaller instances, this is really good solution to start with in order to begin your journey with predictive maintenance. If we would like to answer the question why we created those applications, I would say that this happened when we were working in a couple of greenfield projects where there was no historical data, but the customer wanted to pinpoint the, let's say, operating points, anomalies that were appearing there. So addressing baby problems of the installation. And the reason is simple. The applications, they are accessible for every device, every signal without the need for historical data. The second thing is they have a high scalability because you can test even one machine at a time and focus on the individual signals there just to pinpoint what is interesting from your perspective. And you also have a low entry level, which is really helping to do the fast and easy implementation also with testing. And in principle, having this on board, you also aim to solve crucial problems, detection and prediction of deviations from normal modes, or detecting the anomalies, pinpointing those without the need of getting really to a whole plant data. And with that, I would give my voice to Grzegorz, who can deep dive in the applications themselves. Grzegorz, the floor is yours.
All right, thank you. So let me start with the first step, the trend detection and monitoring. So we can imagine a situation that, for example, we have a pump and we measure the vibrations, and slowly over some period of time, we observe that this level of vibration is higher and higher. So we have some kind of trend, increasing trend in the data, but it's hard to spot. Maybe the trend is like 3 months, 4 months, and it's hard to spot if we observe the actual value. But at some point we can wake up and, oh my God, it looks bad. It's so high when it happened. And to answer this question and to prevent such situation, it's the trend monitoring app. So it allows us to observe a lot of signals simultaneously and detect if there is some kind of trend in the data. It is able to detect the trends with different time horizons, and it's also important that it's able to detect, we call it higher order trends. So not only linear, but also, let's say, for example, logarithmic trends. That's the first. And the second, what is possible with this app is that it allows us to extrapolate the detected trend. So if we detected the trend, we can ask the question, okay, so if it is increasing when we reach the threshold and when we exceed it, let's say some kind of technological threshold, and with the app, we are able to answer this question. So, for example, in 3 or 4 months, the threshold will be exceeded. Of course, everything is automated. So what you see here is the dashboard of this app. You can see that there is a couple of parameters. You can see how it looks like on the visualization, but in fact, there is no need to dive into the parameters of the method. Everything is automated. So we deploy the application, detects what time horizon is important, and how to choose the correct parameters to be the best what is possible. Going up to the next app. So the next app is the change point detection. So again, let's imagine that we have some kind of pump, and the level of vibration is more or less constant over the time on average, but at some point it starts to jump very quickly. So the level of variations in the signal change significantly at some point. It may indicate, for example, that we have some kind of loose sensor or other kind of problem. But again, it's hard to spot because the values jumps around some correct level, so like the level which was observed previously, but the variations is much bigger. And if you would like to detect these kinds of changes in the measurements characteristics, we can deploy the change point detection app. It will automatically analyze different characteristics of the signals to detect if there is some change, also in higher order characteristics. So not only in the change in the mean value, but also, for example, as in the example, change in the variation, the standard deviation, maybe change in kurtosis, the higher orders of the signals. And again, everything is of course automatic, but also possible to detect changes in the characteristics in different time horizons. So some changes, like some in variation, may be short, but some change may be visible over a longer period of time horizon. And again, the app allows us to automatically observe different time horizons, and will be notified if something is different in the measure.
I think, Grzegorz, it is worth to mention that you can have in parallel many different time horizons observed, which can give you some insights based on different frequencies there. Yeah,
exactly. Okay, going up to the third applications, it's anomaly detection, one-dimensional anomalies, and let me describe what we think. So, what these one-dimensional anomalies are. So, let's imagine this time a simpler example. We have a cell phone, a smartphone, and we are using it on a regular basis. And the temperature of it is, let's say, something between 10 degrees and 30 degrees, for example. Of course, there are probably some technological thresholds set by a manufacturer, but it would be something around 90 or 100 degrees. If the temperature will reach this threshold, then the smartphone will be shut down probably. But at some point, we can observe that the temperature is slightly higher or much higher, like let's say 50 degrees. It may indicate that there is some issue with the phone. Maybe it's lying on the sun too long, or maybe there is some virus installed on the phone. So something wrong is going on. We are far from the technological threshold, but we are also far from the normal mode, normal operating mode of the phone. And the same can be applied to industrial installations. So we observe, so the applications, this anomaly detection application is able to define and detect the normal mode. And if...
Yeah, Gregor, sorry to interrupt you. We have a question from the audience. Is it possible to review the history of events? Yes, it is possible. The applications also give you the possibility to communicate with, let's say, external APIs. So you can send this information to any other system, but also through an email, through a SMS, etc. But in application itself, you have the possibility to review the events.
Okay, so the one-dimensional anomaly detection app, as I said, it allows us to detect the changes from the normal mode. So if the temperature is higher than it was observed previously, if the vibrations differ from what was observed previously, and so on and so on. And on the left-hand side, you see the aggregated summary, so this circular plot, because the focus of all of these apps is they focus on the signals, on a level of a signal, but there could be a lot of signals, like thousands or something like this. And we can present the aggregated information in a clear fashion. So if it's green, it's okay. If some of the bars change to yellow or to red, then it indicates that something wrong is going on. As we see on the left-hand side, the signal on the right side of the panel is exactly this red signal on the circular plot. So we clearly see that the threshold, that the level is much higher than the observed one. On the left-hand side, on the right-hand side, we see that we are able to calibrate the method if necessary. Then we can calibrate it by themselves by hand. But as I said, there is no need for it. So all of these applications are fully automatic. So in fact, if you would like to tweak something, then it's possible, but there is no need. It will calibrate themselves automatically. Okay, and going to the last one, the last application is the correlation monitoring. So we can, again, imagine the situation that, for example, we have some kind of electrical motor, and we measure the temperature on a different winding of that motor. So they should be highly correlated. They should behave in the same way, maybe not exactly the same values, but the behavior of the signals should be exactly, more or less exactly the same. And the role of this application is to automatically first detect the groups of highly correlated variables, and then it will automatically analyze and notify us if there is some change in the correlation within the group. It may indicate, of course, some kind of problem with the installations if some signal from that group will differ. And what we see is the summary, the visual summary of the indication of the app. So the most important part is this big green square. If it's green, then everything is okay. There's no point to worry. But again, the applications are not only automatic from the point of calibrations, but they are only fully automatic from point of reporting. So there is no need to observe this dashboard on a regular basis. If something wrong is happening, then the application will send the notification. And then, of course, we can deep dive into the situation.
Yes. Grzegorz, we have a second question from the audience. The question is as follows. If I have all 4 apps, do they communicate with each other? Do they share the data? Yes, this is actually possible. And then you can leverage on, let's say, common workflow there, because each of the apps is able to deliver insights on different level of the change or the anomaly that is actually appearing. Yeah.
So let me jump to the summary. So as Piotr said, the applications are complementary to each other. So they solve the fundamental maintenance problem. They observe if there is some difference from the, let's say, the correct way that the installation should work. And it could be detected in different ways, and all of them could work separately, but also they could communicate with each other and be fully complementary to each other. Second important point to mention is that the apps do not require historical data, and in particular the failure data. So we can deploy the application, as also Piotr said, on a new installations with any prior failure situation, and it will be fully functional. The third point is that the applications offer a low entry level and easy scalability. It could work on, let's say, one signal, even on one signal, but it could also easily scale to thousands of the signals. And the last, they form an excellent base for further more advanced solutions, the full predictive and prescriptive maintenance using the RSIMS platform.
Yeah, and I would also add that on the way, the applications are gaining knowledge. So, for example, if there is an anomaly that appeared in the second type, they get into this mode, recording this kind of events and learning on the go when the data is flowing. So on one hand, we are not requiring the historical data to be available there, but on the other hand, the applications are able to learn along the time. So this is, I think, one of the crucial statements here to mention. And if you have the possibility to have four of those approaches, as I said before, you are able to address different kind of phenomena on different levels, although connected with the same space of problems. So abnormal behavior, different correlations, anomaly detection, etc. Okay, I see that we have another question. Can you give some examples of data sources that can be connected? PLC, historian, raw sensors data, Excel sheet, and how they are different sources connected? And do the apps collect real-time data or bulk data? So I would say here you have different kind of possibilities. In terms of connectivity, you can address either directly from PLC, historian, or raw sensor data, or even you can get the batch data. In principle, the operation of the applications was designed to work in real time, but we are also able to get the bulk data, like the batch data, getting it once a week or once a day, depending on the needs. The idea is that we will have the availability of the applications through the cloud, but they would be also available on premise. With the cloud, it's much more feasible and scalable from let's say implementations and speed perspective there. But in principle, we are not limited to certain protocols. If you think about the low level, is it let's say a Profibus, Modbus, or you have a translator that is going to a OPC or any kind of historian protocol type. So it's quite versatile, and we are now having let's say alpha testing, which will be available from February 2022. For now, we are sending invitations to all of you that participated in the webinars. So you have, let's say, premium access available from the January. Yeah, okay, we have another question. How is maintenance engineer and operator alarmed if one of the algorithms detects or predicts the problem? So here you can have different things, depending if you have your system connected directly to the applications, or you have an API, you can send the data back to the main system, which can be placed, for example, on the cloud, and then the information flow also depends on the design from the IT and OT perspective. But we also give the availability to, as I said before, send an email or an SMS to a dedicated mobile device, or you have the access to a dashboard if you are looking. But alarming in, let's say, real time, usually done via email or SMS there. So connecting this, unless you have a operator that is constantly looking on different dashboards and screens. So of course you can have an alarm with a proper sound and putting some certain information in red, let's say, in order to pinpoint the focus of the maintenance engineer or operator who is looking at the dashboard. So those are the ways. I think I have answered all of the questions from the audience. So thank you very much